हाय फ्रेंड्स, हम आज इन्वर्स लैप्लास ट्रांसफॉर्म देखने वाले हैं। पहला चैप्टर वो है बीएससी सेकंड ईयर का बीटा एंड गैमा फंक्शन, देन लैप्लास ट्रांसफॉर्म। और तीसरा चैप्टर है इन्वर्स लैप्लास ट्रांसफॉर्म। ये बहुत इजी है। इन्वर्स मतलब आपने पहले वीडियो देखा ही होगा लैप्लास ट्रांसफॉर्म का, उसके अपोजिट है ये इन्वर्स लैप्लास ट्रांसफॉर्म। अब हम इन्वर्स लैप्लास ट्रांसफॉर्म की डेफिनेशन पहले देखेंगे। डेफिनेशन इफ द लैप्लास ट्रांसफॉर्म ऑफ a function f of t is f of s, that is Laplace transform of f of t is equal to f of s. Then f of t is called an inverse Laplace transform of f of s, and we write it as Laplace transform of f of t. This is first definition. What is this? This is Laplace transform. Then we can write inverse Laplace transform. Inverse Laplace transform, that is f of t is equal to inverse Laplace transform of f of s. Like this we can write inverse Laplace transform. Definition is so easy. Simply we remember this equation. Inverse Laplace transform means opposite of Laplace transform. Laplace transform means Laplace transform of f of t is equal to f of s. Then inverse Laplace transform. What is inverse Laplace transform? Inverse Laplace transform of f of s is equal to f of t. Simple. And all formulae are like this, opposite. All formulae opposite. Then we can see inverse Laplace transform, standard formula of inverse Laplace transform. Standard formula of inverse Laplace transform. Already you see Laplace transform formulae. So we can easily solve inverse Laplace transform. You study Laplace transform, so inverse Laplace transform you easily solve questions. First is Laplace transform of 1. What is Laplace transform of 1 formula? That is 1 upon p. Then the inverse Laplace, what is inverse of this? That is inverse Laplace transform of 1 upon p is equal to 1. This is inverse Laplace transform. Then we can write second formula of inverse Laplace transform. Laplace transform of t raised to n. What is Laplace transform of t raised to n? Gamma of n plus 1 divided by s raised to n plus 1. but we know gamma of n plus 1 is n factorial divided by s raised to n plus 1. But here n is then we can write inverse Laplace transform, that is t raised to n is equal to inverse Laplace transform. Here n is constant, so shift here divided by n factorial. Inverse Laplace transform of 1 divided by s plus 1. Inverse Laplace transform of 1 divided by s plus 1 is equal to t raised to n divided by n factorial. Then third formula is Laplace transform of e raised to at. What is Laplace transform of e raised to at? That is also equal to 1 upon s minus a. So inverse Laplace transform is e raised to at is equal to Laplace inverse of 1 upon s minus a. Like these all formulae we can found. Then fourth Laplace formula, that is Laplace inverse of s divided by s square plus a square, that is also equal to, what is this? This is cos of at. Then the fifth formula is Laplace inverse of 1 upon s square plus a square. What is this? This is sine of at. But here also a, so a is constant, so shift here, so divide by a. So then sixth formula is Laplace inverse of s divided by s square minus a square. Only here sign change. This is also equal to hyperbolic cos of at. H is hyperbolic cos of at. When we can write hyperbolic sine and cos, so here is only sine is negative. Okay, always same. So then seventh formula is Laplace inverse of a, not here, a is constant, so s square minus a square is equal to sine hyperbolic at divided by a. This is all formulas of inverse Laplace transform. Then we can see theorem first. Linearity property. Linearity properties, that is also called as theorem first. We can write, if f1 of s and f2 of s are Laplace transform of f1 of t and f2 of t respectively, then Laplace inverse of c1 of f1 of s plus c2 of f2 of s is equal to c1 Laplace transform of f1 of s plus c2 Laplace transform of f2 of s, where c1 and c2 are constant. Then we can proof here. Their proof is we know the Laplace transform given we know the Laplace transform. What is Laplace transform? Laplace transform of C1 of Laplace transform of C1 of F1 of S plus C2 of F2 of S is also equal to C1 of, here is Laplace F1 of t and F2 of t, here is capital, so is equal to C1 Laplace transform of F1 of t plus C2 Laplace transform of F2 of t. So like these we can write inverse Laplace transform, that is inverse Laplace transform of C1 F1 of S plus C2 F2 of S is also equal to C1 Laplace inverse of F1 of S plus C2 Laplace inverse of F2 of S. This is linearity property. This is theorem first we can prove here. So then we can use theorem second, that is shifting property. Theorem second, first shifting property. If f dash Laplace inverse of f of s is equal to f of t, then Laplace inverse of f of s minus a is equal to e raised to at f of t. We can prove this is Laplace inverse of f of t, f of s minus a is equal to f of t. Proof we can prove this theorem, that is we have. Then we know the Laplace transformation, that is f of s is equal to Laplace transformations of f of t, that is also equal to integration 0 to infinity e raised to minus st f of t dt f of t dt. Then here is s is s minus a and here is s, so s replaced by s minus a, so then f of s minus a is equal to Laplace transform of, no, here we get equation already, integration 0 to infinity e raised to, here we can put here s is minus s minus a t f of t dt. When we can solve this equation, then integration 0 to infinity integration 0 to infinity e raised to minus st into e raised to a t f of t dt. But here at is constant. Our equation we can solve this, then we arrange this, so integration 0 to infinity e raised to minus st f of t dt, and here we can write at, but we know this is equal to, here we can write f of s Laplace transform of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. So this is also equal. Then Laplace transform of f of t e raised to at so this is Laplace transform. So inverse is Laplace inverse of f of s minus a is equal to f of t e raised to at. Here Laplace. So here we can write. So what is here right? Laplace inverse. So our theorem is proof. So thank you for watching my video, and subscribe my channel on YouTube, then like it, and our comment box, comment comment these videos, how we can change of my writing, or you what you understand. So thank you.